Alright guys, today we're going to be discussing even and odd functions. Okay, so we're going to be discussing them in two ways. You can discuss them algebraically and find out how to identify them algebraically, or you can discuss them graphically and identify them graphically. I probably misspelled both of these words, so please don't destroy me in the comments. Anyway, let's get into the conditions for even and odd functions. In order for a function to be considered even, it must satisfy the requirement that f of negative x equals f of x. Okay? For a function to be considered odd, it must satisfy the requirement that f of negative x equals negative f of x. And we're going to see examples of these in just a moment. And in order for a function to be neither, it just needs to fail both of these requirements. Okay? If it's not even and it's not odd, that means it must be neither. So now let me give us an example. Let's say I am given f of x equals x to the fourth power plus 3x squared. Okay? So the very easy way to go about doing this is I want to look at all of the x terms in my function and I want to look at their exponents. 4, is that an even number? Yes. 2, is that an even number? Yes. That means I have an even function. It's literally that simple. Okay? But if we want to really prove ourselves or show work, if your teacher wants you to do that, you can say that the condition for a function being even is that f of negative x equals f of x. So let's rewrite this function down here, but instead plugging in f of negative x. That's going to give us negative x to the fourth plus 3 times negative x squared. Okay? We know that whenever you multiply a negative by a negative, you get a positive. So I'm going to break this negative x to the fourth into negative x squared multiplied by negative x squared plus 3 times negative x squared. Okay? So negative x squared is the same as x squared. Negative x squared is the same as x squared. X squared times x squared equals x to the fourth plus 3 times negative x squared equals x squared. Does this equal that? Yes, then we have rigorously proved that this function is even. Now let's take a look at an example of an odd function. F of x equals x to the fifth plus 2x to the third. We look at our exponents. Is this odd? Yes. Is this odd? Yes. That means this is an odd function. Boom, bam, bop. Now let's see if we can rigorously prove it using our condition. F of negative x equals negative f of x. Okay? Whenever we raise a negative number to an odd power, b, then our resultant is going to be a negative number. So negative x to the fifth is the same as negative x to the fifth. Okay? And negative x all to the third is the same as negative x to the third. So that means that if I rewrite this function f of x down here as negative x to the fifth plus 2 times negative x to the third, that's going to equal negative x to the fifth minus 2x to the third. So I'm going to factor out my negative 1, and I'm going to rewrite this as negative 1 times x to the fifth plus 2x to the third. Okay? X to the fifth plus 2x to the third is my original function, so f of negative x does indeed equal negative f of x. Okay? So we have now rigorously proved that this is odd. But if you ever need a shortcut, just look at the exponents, and that's how you determine it very easily. Now let's take a look at another example. F of x equals x to the third minus 5x squared plus 2. We look at our first exponent, that's even. We look at our second exponent, that's odd. We have conflicting even and odd. That means we are neither. Okay, this function is neither. A very quick and easy way to show that. Okay? And if you do the whole arithmetic, if you do try to go through the whole formula and all the conditions, as we did up here, you'll quickly realize that this does not satisfy the conditions for odd nor the conditions for even. Now, we are going to take a little bit of time to consider our even and odd functions graphically. Okay? What do they look like? The condition for an even function is that it is symmetric about the y-axis. If you reflect it across the y-axis, it's going to look exactly the same. Conditions for an odd function is that they are symmetric about the origin. And of course, if they fail both of these requirements, then they are neither. Okay, so let me give you an example. Let's graph f of x equals x squared plus 1. Let's graph it. Okay, so you'll see here that f of x equals x squared plus 1 is an even function. Why? Because the right side of the graph looks exactly the same as the left side of the graph. The two sides are symmetrical over the y-axis if the right side exactly resembles the left. Now let's consider a different example. Let me give you f of x equals x to the third. We know that 3 is an odd exponent, so we already know this is going to be an odd function, but let's demonstrate it by graphing it. A function of x to the third looks like this. Okay? So symmetry about the origin is kind of hard to see with your eyes just looking at it. So a bit of an easier way to visualize it is if I take this part of my function and I rotate it around my origin 180 degrees, will this be exactly the same? Will they exactly overlap one on top of the other? And if I do that rotation, and if they do exactly overlap, then I'm looking at an odd function. Okay? Another example would be, let's say, f of x equals the absolute value of x. That looks like this, which would indeed be an even function, because the left exactly resembles the right. Now, we can even observe our trigonometric functions. If f of x equals sine theta, let's draw, well, not sine theta, excuse me, sine x. We can draw that on our table, and it's going to look like this in both directions, of course. And we see here that if I just take a little slice of sine x and I rotate it around the origin 180 degrees, it's going to look exactly the same as this slice right here. Therefore, I am dealing with an odd function. Sine x is an odd function. Next, I could look at cosine x. Cosine x starts up here and then continues to oscillate as such. Cosine x exhibits symmetry about the y-axis. The left side looks exactly like the right. Therefore, cosine x would be an even function. Cosine x would be even. Let's take a moment to observe the behavior of a linear function. A linear function that goes through the origin will always be odd, because if we take a look at f of x equals x, there is secretly an exponent of 1 here, and if we look at the exponent 1, that's going to be odd. So we can analyze it both looking at the exponent and looking at the graph, which is why I keep iterating again and again that it is important to know what your graphs look like, because it allows you to have a second sense of security, a second sense of assurance that your answer mathematically is right. Now let me give you another example. Let's say I have this sort of sideways parabola. Okay? Is this even or odd? Well, it's neither. Why is it neither? Because the left side doesn't look like the right, and if I rotate it 180 degrees about the origin, then it's just going to look like this. So no, it's neither. Also, it fails the vertical line test, so it's not a function. So it can't be an even function if it's not even a function. Now this one is what I'm going to leave us off with, and it's kind of a trick question. If I have a circle, is that even, odd, or neither? Take a moment and think about it. Pause the video and come back when you're ready. So first of all, we can split this down the middle and say that the right side is the same as the left side. So we know it satisfies the conditions for even. But if I rotate this 180 degrees around the origin, then I'm still left with the exact same circle. It's going to look exactly the same. So it meets the conditions for odd. However, this isn't a function. It fails the vertical line test. So I can't call it an even function. I can't call it an odd function. So I have to say it's neither. I have to say that it is neither because in order to be an even function, you need to be a function. And in order to be an odd function, you need to be a function. Alright guys, as always, if you have any questions, please join the Discord, and in any case, enjoy life.